Tim, thank you so much for coming over. You heard his schedule, but he has ahead of him to take time out to come over here to Northern Ireland to speak to us all. Thank you very, very, very much. There's just another person coming in. Tim, as you would have all known, Tim has a PhD in genetics and hopefully can provide some insight into how the myostatin works in cattle. Somewhere now between 80 and 90% of the cattle of the existing Irish Moilies have been slipped, with a small percentage of the cattle showing up as carrying a single copy of the myostatin gene, most likely originating back to the grading up programme back in the 80s. So rather than the society doing nothing, we got straight to work. So the aim, as I keep saying, of the society is to ensure the preservation of the breed, to promote and encourage the improvement of the Irish Moilie breed, whilst maintaining the breed's purity, the breed's characteristics, which obviously would be compromised possibly by the myostatin gene. So really, therefore, the society has taken the decision to discourage the myostatin gene in the breed. And the actions that were implemented by the society were, first of all breeders who owned bulls that carried one copy of the myostatin gene were notified before the end of March. All breeders who owned females carrying the myostatin gene were then notified before the end of May. So that was the society contacting those breeders. The society have made the decision that any double carrying bulls will be immediately entered into Class 2. However, there has been no animals yet to be found to have the double carrier. All animals are to be identified in the herd book that carry the myostatin gene. This is a work in progress at the moment with Gillian, working very hard with grassroots to get this implemented as soon as possible. Bull calves that are born after the 1st of January 2024 carrying one or two copies of the myostatin gene will be entered into Class 2 of the herd book. Females born after the 1st of January 2024 that carry two copies, not just, the two copies of the myostatin gene will be entered into Class 2 of the herd book. So the society agreed that it was important to educate individual breeders about the myostatin gene, so you can make your own decisions what you would like to do. And this is what tonight's all about. Tim's going to give us an insight. So thank you very much, Tim.
Thanks, Michelle.
Okay.
So, hello everybody. So as Michelle said, from a SINS PhD in genetics, I think the only relevance of saying that is it means that I understand the research and can hopefully communicate it to you in a way that makes sense.
What I'm not going to do is tell you what manual you should read, that's up to you. All I'm going to do is give you information. What I'm going to tell you is facts, things that have been proven scientifically. I'm going to give you an opinion or a story. I'll tell you what's known. I can't tell you about what's not known for obvious reasons, but hopefully it'll help you navigate through and understand what you want to do with your own breeding. And I'm going to try and keep it just in plain English, so there's no highfalutin scientific words, but I'll try and explain things, because some of the words will be more okay. So, myostatin is their myostatin statin. So, when you've got to a certain point of your development, and we have myostatin, all animals know. When you get to a certain level of your development, it stops things going. Same way that it is a growth regulator, growth gene. Obviously, in the worst case scenario, you could have situations that it can never stop being used in animal. We don't know to know all the other things. In the normal wild type animal, you can ask yourself, why is it there? As I said, it can stop development at a certain point, and then it's reason. So, worth bearing in mind. other stuff I'm going to tell you, just bear with me, because some of you may know. So what a gene is, so myostatin is a gene. Gene is a little segment on your chromosomes, on your DNA, that actually has a function. Basically, it acts like a little blueprint, so that a zipper runs along it and makes proteins. And proteins are just on when you can imagine a slinky spring, to pull it out along, that's what it would look like when it came. You let go. There's all electric charge. That's what that interacts with the musculature, but also other tissues in the body. And stop growing, also where other characters. The what we say here is weird characteristics. The other things that are going on, and we can say. So, protein is there's lots of other ones. You'll know about hormones like and keratin. So, just imagine that they all do different functions. About one. The little picture of the bottom gives you an idea about how it works. You've got your zipper, if you like, the translation. You produce your amino acid chain. And that all you join up. That all scrunches up and it's left around to do its particular. So that's the science bit mostly. As I say, myostatin, when it's not mutated, is called wild type. Second form myostatin, or a version of myostatin. And interestingly, even in humans, there are people who are born with myostatin mutations. So they look like bodybuilders, basically. And it's really sad to see them here in children, but they have incredibly developmental children. And interestingly, often don't live long into the proper name myostatin is growth. So as I said, it limits muscle that we have in the diaphragms, the skeletal muscle, which is we also have heart muscle, which is particular. And interestingly, it does impact the heart muscle quite a bit. Now we a double copy, and you butcher it, and you slice through the muscle, you will see a difference both on the outside of the muscle, but very importantly also on the intramuscular fat. Now you do get intramuscular fat in double copies, but it often takes a long time for that to grow later in the development of the animal. Cardiac muscle, heart muscle. You often see bigger hearts in these animals, but the hearts actually are generally bigger than you normally see. This is all also in scientific papers. Sometimes that can be probably and it also impacts on the size and development of the gut. So one of the interesting things about particularly animals with double copies, we see this with extreme versions, is that they'll do well. They particularly well though on a cereal diet. And that's because there's more volume of food going in, but actually all the animals produce. So these are great practically zero grazing, zero feeding, and yes, Sarah will be going to development. The mitochondria are the little bits within cells which produce all the energy. I mentioned about the energy production. There's been a huge number of studies now that show that there are fewer mitochondria in the muscle or volume. So again, animals can mobility, and that's particularly true. All these things I'm telling you are not opinions, they're all based on proper science, and that's what we do know. Now, the other thing I said is it's becoming clear that in the development and what it breathing, there's not just one thing. You don't need to sort of necessarily try and translate this picture. The point is that myostatin, a little bit of protein, interacts, so this is the inside of a cell, this is the outside of the cell, binds onto the outside of the cell, and put it like we were chatting earlier about that sometimes copy myostatin on the wall, and you breadcrumb, and then you get some progeny that don't carry myostatin, you still seem to have some of the carcass characteristics that you have myostatin. And that's generation. You can be student of the myostatin. And it's certainly true in short characterizing.
And again, we'll talk about that when we talk about the different mutations. I think I'm repeating basically what was said in the research I described before about fat deposition and where it's deposited, bone development, organ size, energy conversion, and other metabolic and development systems less well characterized are impacted. So, we tend to select animals on the basis of what we see, but there's a lot of other stuff going on, and that's why I wanted to just mention about if you butcher these animals, you will see differences in carcass. Some of which, may be beneficial in terms of carcass classification, but it depends on the meat market that you're pushing your animal into. So what I'm saying in the normal gene is, so the wild type in the wild, the complex interaction has evolved to work in balance. So if you've got all these things happening all the time, you can imagine in evolution, it's taken hundreds of generations of the precursors to modern cattle to get to a balance to make that animal viable. So if there are issues around, and then one of the other issues to mention is the impact on birthing, is there are issues on pelvic scores, but also on average calf weight. If the calf isn't getting out in the wild type, obviously it's going to be a negative pressure on evolution. They're going to die if they're not in a cared for situation. So again, that's why the balance has evolved. Now, let's just say a bit about the deletions. So what I want you to hold in your head is this picture of one half of the zipper. And so there's two things that can happen. The first is that there are bits of the DNA that, through the mutation, have disappeared, for the better description. So that when they try and make the protein on the other side of the zipper, it either doesn't form the whole protein, or it forms it in a way that when you're trying to, with your slinky spring to let it go, it forms a completely different shape. So when you had that picture of the cell, and there's let's say there was a lock on one side, and we imagine the myostatin is the key. If it's a different shape, the key will not fit the lock. So then it just will not work at all. And when myostatin in its wild form doesn't work, then that is exactly when you get the situation of the physiology, the carcass conformation like a Belgian balloon. Basically all the control is gone. The myostatin doesn't stop any or regulate any muscle development. So that's the first thing. The one that a lot of people are interested in is where it partially works. So you don't get the extreme loss of the muscle regulation, you just get a partial loss. And this is where, and I'll just go through in a minute, but this is just where the Limousin's talk about the predominant version in the Limousin cattle as the profit gene, because it's not bad enough on the physiology to mean that they can't get a an animal to market. It can look absolutely cracking, you know, and you can win shows and all the rest of it. But do be aware it will have some of the attributes. So I've coloured them different colours to map with whether they're the deleterious, the ones with the big deletions that don't work, or the partial ones that partially work. Most of these have occurred in particular breeds spontaneously, and then stayed within that breed. And it is quite rare for a mutation that has started in one breed to get into another one spontaneously. Generally, it has to be by possibly through grading up or crossbreeding. It can happen, but it is extremely rare. So even in shorthorns, you know, we can say, because the grading up we did in Mine d'Anjou, actually it's pretty much come from Mine d'Anjou. And what we do have is an ongoing debate. People say in shorthorns, oh yeah, well, you know, the Belgian Blue came from shorthorns, so, you know, it's a natural occurrence. Actually, the original Belgian Blue cattle didn't carry it. And actually, if you go to Belgium, there are still Belgian Blues that don't carry the deletions. So it just is quite interesting to see that we tell ourselves some things based on what we believe, but the reality sometimes doesn't back it up. So that just sort of shows where these things are from. So I say there's two predominant in shorthorns that I know about. The bottom one, H, is less prominent, and that's the one that has been dubbed the profit gene as a great bit of marketing by Limousin's, and that's absolutely fine. And then lastly, you have the situation where there's no mutation at all. So you know, when I take this slide off, just have in your head, there's versions that don't work at all, and that's your Belgian Blue type. You've got versions that partially work, and they're your partial types. And I'll talk a little bit about the partial types because, again, there's some opinions about are they different and do they work in different ways. It's very difficult to find any science to support, real science that supports that. And I think, again, you've got to sort of tease between what is great marketing and actually what's known by science. And I say that in a purely objective way. So, now the other bit most people ask is, so if I've got two different versions of the myostatin in terms of the big deletions and the partial, you know, if I mate them with different things, what happens? So I'm just going to talk you through that. So the big deletion version I've done in red. And so if you've got any of these versions where basically the protein doesn't operate at all in either allele, if you breed one with the other, so basically that's your fully blown myostatin, double muscled conformation, you'll get the extreme phenotype that you will see in Belgian Blues. Now, just a little bit of a warning on that. Because I said some other genes were also involved in it, you may see in some breeds that it might not be quite as extreme as Belgian Blue. They'll still be like a bodybuilder, but it might not just be as pronounced, and that's because there is a slight bit of control creeping in. The next one is, so what if I mate it, one of the deletion genes, with one that partially works, and it doesn't matter which one you do it with. This is a really important point to take away. It doesn't matter which of the partials it is, they will all more or less have the same partial effect. Some work slightly better than others, but it's a very subjective opinion about whether this one, you know, produces a wider loin, or this one has slightly more muscle than the other, and it's too variable to say for sure. But basically, what you can say is it will have a much reduced myostatin function, and it will probably be
look like quite a muscly Limousin, but maybe not too extreme. It's probably the most accurate way you could describe it. The next one is, well, what if I get one of those alleles that don't work at all, and then I do it with a wild type, one that isn't a carrier? Well, you'll still have some musculature, and actually this may be where you want to be, but it will be reduced, and that may work well for people who are doing first crosses, to be honest. Then the last two, if I have two partial versions, and again I'll make the point, it doesn't matter which of the partials they are, you'll just have a reduced myostatin function. So again, maybe like the profit gene in Limousin, that's not too bad. Maybe you get great first crosses, maybe you get great second crosses. But you may have some carving difficulty. It depends on the individual animal. And then lastly, if you have the wild type with the partials, that's the least extreme of all. And so in a sense, that does relate to the Limousin situation, because a lot of Limousin breeders are trying to go for single copies, so they get that balance and they get some longevity in the animal. Right, so let's talk about what's good, what works well for cattle breeders in myostatin. So certainly conformationally wise, it has certainly over the last 10-15 years become a popular look. So if you, dare I say it, if you had a myostatin positive Moilie or a double copy calf, maybe through a crossbreed or whatever, and you put it in the market alongside Angus and Limmys and Charolais, apart from the coat colour, you may not see a lot of difference, and maybe that's good economically. You'll get the higher dress out percentage because the gut's a lot smaller generally, and you've got the increased protein mass, and your fifth quarter is often smaller. You've got a reduced fat to protein ratio because you've got less back and intramuscular fat, and of course we have got into, particularly with supermarket trimming, the supermarket trimmers like that because it makes their job a lot easier. It's easy to fit into the little plastic containers and so on and so forth. So basically in terms of market, that's good, and the reduced bone mass is also good for that sort of cheaper protein supermarket approach to things, so that's fine. On grain cattle, double muscle cattle have been shown to give great feed efficiency because they do convert high carbohydrate, high protein grain well into muscle, and there's absolutely no question about that. The same is not true, and I'll say this when we talk about the downside, is not true on extensive systems or pasture-based systems. There will be some exceptions, but interestingly, if you look at Limousins and you go to Limousin in France, very few of those animals will be carrying myostatin deletions at all. They'll look more like how we expect the conformation of probably a suckler cow that looks more like a natural Angus or a natural Shorthorn. Now this one's interesting. There are claims that there are high polyunsaturates to saturated fat compared to grass-fed or total pasture-fed, and actually I went back to look at the research, and I'm not sure that it would pass muster. It's not peer-reviewed. It's not done by agri-scientists. A lot of it was just observational data, and what they did was it was a nutritionist who tried to look at it, and actually what they found out was that the cattle were actually crossbred with lots of other different cattle, so it didn't really, it wasn't that meaningful. Another good aspect, particularly in the days where we're thinking about carbon and all that agenda, where they're trying to push for earlier kill dates, you will get an earlier maturity, you will get an earlier kill date. Now, interestingly, that happens more with the crossbreds, where you've got the hybrid vigour. Actually, on purebred myostatin cattle, what you are finding there are cattle that take a lot longer to mature. So I don't know, does anybody in here breed Dutch Texels? Well, with Dutch Texels you see something very similar. So if you've got the kind of anglicized or Northern European version of the Texel, the Scottish version of the Texel, which was quite different from the Dutch Texel. Your hybrid Scotch Texel will mature really well and quickly. Your Dutch Texels will stay small, and so when you actually take them to market, they look like poons compared to everything everybody else is selling. But they actually, in terms of weight, meat per weight, will probably equal it. So there is a market perception thing. So that's the benefit side. So there's quite a lot of benefits if you're into producing fast turnover, cereal-based on a beef system, and maybe you've got a contract with a supermarket or a more commercial abattoir. So what are the issues? Now, I went through all the credible literature to see what the objective view is and what was based on research. And that's both the States, Canada, this country, and Northern Europe and Australia. One of the interesting things was the cattle were much more susceptible to respiratory disease. If you ever come to my farm, what you'll basically see is you'll see two big sheds, and we're in the side of a hill. We're quite a humid area. So in a cattle building, you can imagine it gets quite humid. On our farm, before we arrived there 30 plus years ago, they used to breed Belgian Blues. And the respiratory problems they had, because it was damp, were dreadful. They had a mortality that was up at 20%, particularly on young calves. And the building is full of electric fans as a consequence, and in fact they'd opened the roof up, which wasn't particularly helpful, because basically these cattle just couldn't expand their lungs big enough, just because the muscle bulk, to be able to get enough throughput to basically breathe in and out clean, good air basically. They have problems with the urinary system, so they'll develop stones, and often see in male sheep you'll get the stone in urethra, and that happens quite frequently in the male animals, and that's because their kidneys don't, if you like, separate out all the calcium deposits, so basically they crystallise in the urethra. They do get lameness, but I think a lot of that's about how much weight is going down on the hoof, and you see it in you see that in Charolais sheep and in Texels particularly. They'll get a lot of foot problems. Interestingly, they get what's called nutritional stress susceptibility. So a bit like when your cows are basically get milk fever. The metabolism can't produce enough of whatever mineral, or assimilate whatever mineral it is that actually keeps either the muscles going or the milk producing. Quite a lot of that happens with these animals, so their metabolism can't keep pace with all the bulk that they've got to carry. And because I mentioned earlier that they're missing out on the number of mitochondria in the cells, that's making it worse. They get heat stress, which all follows. I mentioned about difficult births. But one of the interesting things about difficult births, and we saw this, so one thing I'll share with you, this is just based on direct experience. When we moved from commercial cattle and we moved into shorthorns, we did, I think what quite a few people do is, we tried to recreate the commercial cattle with a shorthorn coat on. So we were doing embryo transfers from Canada, and we were selecting for myostatin. And we did, in true objective honesty, we did have birthing issues. If we ever had a double copy, they had to come out the side door. I think we ever had one that didn't. But the most disappointing thing was that when we did have a single copies, and it was variable, there would be big calves. And the issue wasn't trying to get the hips out, where you're sort of switching them on the sides to try and pull them out. It would be that they would get stuck on the chest. And they get stuck on the chest before the nose was out. So what would be happening is the bag would break, the nose would not even be out, because they were so tight in the birth canal, they were pulling the amniotic sac off them, but they were also crushing their umbilical cord as they were coming out. And by the time you got them out, they were dead. So, and of course, what if they did try and take a breath, because of the size of the birth canal, because of the breadth on the spring of the rib, they couldn't expand the lungs. So, and that happened about 5 times, and it was very, very upsetting actually. And of course, they're always our best calf by the time we come out. So there are issues. That said, to just give you a completely objective view, there will be people who will say that they don't have those problems, that all the calves just drop out, etc., etc. I'm not sure how much that will be wishful thinking and how much they want to show that the herd does well. And there will be examples where things work, but our experience was to the contrary. One of the other things, and this was really interesting, there's a recent paper on this, getting what's called psoriatic mange, which is basically a system where their immune system starts to cause almost like a psoriasis, but it means a susceptibility to mange lice as well. And it's because the immune systems don't work just quite as well as they should do. Longer gestation period, so we go back to the bigger calves. I talked about skeletal development. We talked about it as a positive because obviously the canal percentage is improved. But to carry a lot of muscle, you've got to have a big frame to patch it onto. Now, if you're managing to kill out at 18 months, that might not be an issue. But if you're trying to breed cattle consistently, then it can become a big problem. I talked about the less marbling in the meat, which may not matter to you. I think certainly for a lot of native breeds, the premium market on meat is about the marbled meat and the provenance story. That's what we find with the short horns. I mean, we kill our own animals, most of them. We started doing the thing about 8 years ago where we were killing the cold cows ourselves, and we hang them ourselves and we put them into the human food chain. So they're cored, obviously, to meet all the BSE requirements. But we basically mature those, depending on the prime cuts, 6-8 weeks. The meat almost goes black. We sell it to restaurants, and so we can get a clear profit, and this is actual profit, of over £3,000 a carcass. Now, there's about £600 a cost in terms of processing for us, boxes, transport, blah blah blah. But there is a market we can't keep demand for that sort of meat, and it's back in vogue now that we're past COVID. So restaurants like it. Most people who eat it don't want to go back to your own beef, but you are paying for the entire cost of that cow in its life. But it's a much better, in my opinion, this is an opinion now, in my opinion, it's a much more dignified end for that cow. If you've kept it, it's produced calves for you, than just going off for dog food or pining. But anyway, that is an opinion. And the last one, of course, is reduced milk production. There definitely is, and I'm basing this now on scientific literature, but also on our direct experience with shorthorns. There was definitely reduced milk production. We used to have quite good udder suspension, but the udders themselves were quite shallow, and when they bagged up, they didn't bag up in the same way that the cows that didn't carry myostatin. Now, interestingly, the ones that had been in lines that had single copy myostatin and were bred subsequently without did have good udders. So maybe there is something you can still keep some of the myostatin benefits, but still get back some of the extensive prolificacy stuff. Right. Okay, so sort of coming a bit towards the end there. Best breeding strategy. So what you want to breed is up to you, I would suggest. I know the society will obviously will want to preserve a particular style of animal because knowing the history of the Moilie as I do, I can understand that, as Michelle said at the start. But at the end of the day, whether it's a registered animal or not, you want to breed the cattle that you want to breed, whichever market you think will be viable for your farm. All I can say is this, that if you do use myostatin, you really should genotype both the sire and the dam, because otherwise it's Russian roulette. You don't know what you're going to get, And if you do get a double copy, and there is a whole, I mean, we were talking earlier, there's a debate about how prevalent double copies might be, or why there aren't as prevalent in Moilies. I don't know is the answer. I mean, it's a 1 in 4 chance if you've got 2 single copies, but it may be there's some other DNA mechanisms going on in Moilies. I have no idea, and there's no research that I know of to support either view on it. But at least if you know what you've got, you can plan your breeding, and that will reduce risk to you. So if you want a beneficial carcass change, the suggestion is to only use single copy animals on one side of the mating. Use a wild type on the other, and so you can use your selective breeding to try and get the best from it, but without the downsides. As I said, do your DNA typing on both sides of the mating. Preferably use partial deletions on your single copy rather than full deletions, because that way you've less chance of getting the more extreme downsides. I think, you know, perhaps as a society you want to ask, and as individuals you want to ask yourself the question, what do I want out of my breed, in this case the Moilies? You know, what are the virtues that brought you to the breed? Does myostatin support that or not support that? You know, because there are loads of other breeds that you can choose from. You know, just one to think about. It's up to you. Yeah. And just remember that increased muscling, soft fleshing, improved carcass traits to meet market requirements can actually be done without myostatin. And there's a great example. I was at the Scottish beef event, was it a week or 2 ago, and the Shorn Society put a bull in, and of course we chose a bull that was, you know, pretty good, obviously. But this bull, I wouldn't have known if it wasn't a myostatin single copy. It wasn't, but it had fantastic breadth of pelvis. It was straight right down to its withers. Beautiful loin on it, depth on its back leg. I mean, it was standing full square. It was a good animal. And I think what's interesting is that because all these other things are going on besides myostatin, you can selectively breed for an animal with improved musculature, but also the soft fleshing. And the soft fleshing, I think, you know, when I spend a lot of time talking with butchers, that's what they want. That's the carcass they want. Hard fleshing animals are just a nightmare for them. And of course, actually, that is what happens as you go to the extremes of the phenotype. Great if you're crossing, but not for a carcass animal. It does take longer to get those animals, though, in terms of selective breeding, if you do it without the myostatin. Myostatin is, you know, arguably a shortcut to produce an impressive looking animal in a short period. Or if you want to go direct to crossbreeding and that's your market, then, you know, that's absolutely fine. And I think I might be at the end. I am at the end. So, quick rattle through. There's probably quite a lot of detail. Again, I'm not going to answer questions about what's right for Moilies, because that's not for me to do, but I will try and help your understanding about how their stuff works. Thank you very much.
Tim, thank you so much indeed. You can hear a pin dropping in here. Everybody's listening to you intently. So I'll open up the floor then if anybody does want to ask any questions.
You as a shorthorn breeder are quite happy to breed with females that carry the one copy.
Well,
You think it's a benefit to your herd?
well,
You wouldn't want to go back to no myostatin.
well, I evolved in my thinking about my cattle over time. You know, I go out and I spend hours looking at them and thinking what's right, what's wrong, what's perfect, what's not perfect. And because we cut them up as well, because we've got the carcasses, then I'm also holding that picture in my head. That's a rather long-winded answer to the fact that now all our cows are myostatin negative, all of them, without exception. I've still got some embryos that we collect, we produced, where there'll be some single copies, and they'll obviously, some of those will come out of single copy cow as well. I still got stuff in the tank that has single copy bulls, and I have selectively used them. If I get a single copy bull out of that mating and it's good enough to sell, I would sell it. But actually what I'm working towards is the big square carcass animal that basically has no myostatin. Because it's just, particularly with shorthorns, I've got to worry about coat colour, I've got to worry about polling, worrying about myostatin on top of that. And also because of the difficulties that we personally experienced when we were making myostatin a central part of our breeding strategy, we cattle breeders generally are bad at being honest about the costs, but the costs weren't worth it, frankly. And because for shorthorns, and I do feel qualified to say a little bit about shorthorns. I think that shorthorns, they were what do I call it? The Ford Cortina of cattle at one point. They were everywhere, and they fit whatever people wanted, and they did that mostly because they didn't carry myostatin. They were easy, they were extensive. You could cross them with most stuff, and most crossbreds would be better as a consequence. Yeah. And the breeding was consistent enough that it was reliable. Now, why is that relevant to tell you? So, we have local dairy farms come to us and they love the idea of having some coloured offspring. So, 3 farms near us went to get some bulls from a very well-known herd, not far from a shorthorn herd, not far from us, which used myostatin a lot. And of course, what they didn't know was which of their crossbred milking sucklers, because they used to milk some of the better milking sucklers as well as the pure Holsteins. They didn't know which of those carried myostatin, and they crossed them, and then they got some double copies, and then they had a whole load of calving problems, and we're never touching a shorthorn again. I sell quite a lot of bulls to dairy herds, and I have repeat customers. Now that set what that other breeder did, and them going to the other breeder, set me back 3 years in terms of sales. So I look at it purely commercial. I mean, we farm because we do it to make money. We love shorthorns, we love walking around them, they're pretty to look at, they're quite fun, you never know quite what you're going to get. But at the end of the day, it's got to make us a profit. Each cow has its own balance sheet. If after 3 years, it's not returning me at least a 15% profit per cow, then it goes. We're pretty hard on that. So you can see in that context, given what I explained about our experience, we've bred it out. Now, the question you might, and it'd be very reasonable you to say to me, well, you did it, and you say that there's, some benefits that have been left behind having gone through that. And yeah, I think for some of our cow lines, they probably got slightly more quickly towards a better loin conformation. The other thing I did notice though was a lot of them between the hook bone and the pin bones, you started to see this. So they weren't even, you didn't get a nice flat cover over the plates, and consequently, and we got them evaluated on some of the hip measurements. They actually were tighter over the pelvic bridge as a consequence. It's like you're twisting the pelvis. And the other thing you were getting was that they were getting a little bit cow-hopped because the pelvis was angled in a wee bit. And I do look at quite a lot of them. It's one of the ways I can work out, have a little test on myself. Can I spot the myostatin carriers? And generally they got more pronounced tail head, and they've got that dip between the pin bone and the hook bone. Won't be for every cattle, but it is quite characteristic. So that's my personal opinion. But I've had my play with myostatin, so I shouldn't be denying anyone else the opportunity to do it. I'm just saying that's what we experienced.
Hard to beat experience on it. Only time can tell that.
Yeah, and it might be different. It might be different for Moilies. I have no idea. You know, each cattle breed has got its own particular characteristics. But yeah, I just think it can be. I wouldn't go back and repeat it, but I don't regret having lived through the experience of using it. It's probably the best way to say it.
So, sorry.
Oh, we have to do it. Hiya.
Sorry, I was going to ask you, do you think, is there any merit in looking on the F94L, the profit gene, and a different way from the other 8 myostatin genes? In other words, I've looked into the research published by the Limousine Society.
Yeah.
Now, they claim that research based, I think, on coming from Australia, that started in Australia in 2008, 2009, they would claim that the F94L doesn't lead to less milk, it doesn't lead to harder calving. They would say, I talked to the secretary of the society, and she would claim that it's not a magic bullet. If you have hard calving at the moment, it's not going to improve it. But if you have easy calving at the moment, it's not going to make it difficult. You're going to get more meat, 22% more carcass meat. You're going to lose a bit of the fat. Now I know, depending on which market you go into, a lot of butchers would actually look on that as a benefit, not because my experience was the first Moilies I took to a butcher. The butcher came back to me and he showed me 2 big buckets of fat from a neighbour, and he said, I don't want animals like this anymore. I had sent one in, it was okay.
Yeah.
The neighbour, he asked me to get rid of one. He came in with these 2 big buckets of fat. He said, this is rubbish, I have to throw this out. He couldn't put it into sausage, whatever. So, personally speaking, I don't think that. But gestation doesn't change. All things don't change. And they would claim that the Limousine breed go into all the myostatin genes. In other words, if you want to sell a bull, you put some of these C, H or whatever in, but the breeders always go back to their cow families and they just want F94L. That's what Limousine, they just want F94L in their female breeding population. They don't, these other things are put in to get the big fancy prices for selling birds and blue shape and so on. But they would claim, that girl, the secretary would claim that there's no, I asked her if it was her position, I explained, she asked me what society, I said Irish Moilie. I said if you were in the position of a breeder, Irish Moilie, she said, well, a small breed would be very rash to cut out that possibility with a limited gene pool, because we must remember Moilies were down to about 20 animals, very limited gene pool. The genes in the Moilies, I'm not sure whether you're aware or not, the original Moilie died out, it's extinct because it became so inbred, they just died out. The present Moilies are all as a result of upgrading. Now, the inside of a Moilie, we're marketing them as a beef breed. They go to Balmoral as a beef breed. That's what says on the outside of the tin. Inside, they're a dairy breed, because I can speak from my own herd. They came from Frisian, Dairy Shorthorn, Jersey, and Ayrshire, plus Moilie, plus pure Moilie. I'm not running somebody else's herd, I'm going to say that. Those are the 4 families, my best 4 families. That's how they originated, from those 4 breeds, plus Irish Moilie. So we're trying to produce a beef animal now. I'm trying to produce a beef animal now with some structure, some substance, and not a Jersey type animal. So therefore, I would view the F94L, if the claims are correct. Now, these are claims, scientific claims I would claim the society. I don't know whether they're misleading the public or not by making them, but I certainly would believe them because they're a reputable society. And what they're trying to do, what I'm trying to do is produce an animal with a better structure. So therefore the 20%, 22% extra meat is very beneficial. It's also more tender. They did a test, they said, and they claim it's 22%. They did a spear test, whatever. It's 22% more tender. And there's no downsides to this. And they're talking with double copies. Now, I wouldn't be so extreme maybe at the moment to go for double copies, but I'd be happy just to have single copy females. I've asked a breeder, another breeder, who happens to have some F94L females, and I asked him, do you notice any difference in the pelvic capacity of your females with this? He said no. He's measured these animals, he does that consistently, and he said there's no difference in the pelvic capacity with the F94N. So these problems that you're talking about, I accept they're there, no doubt, but I would put them down to some of the other 8 genes. And as far as I'm aware, the Shorthorn Society don't test for females. They've no idea. You maybe do, but the breeders in general, they haven't a clue what's in their females, how many of these myostatins, because they don't DNA or they don't genotype their females. So a lot of the research is based on guesswork, as you say. It's not a good basis to base on. But if you follow your guidance there to make sure that you know what your animal is, what the bull is, what the female is, I just think, your professional opinion on looking on F94L as distinct from the other 8.
Okay. So that's the question. I'm not going to comment on Moilie, because you can bring what you like.
Oh no, sorry. Just to clarify, what I'm really trying to say is, would you rubbish or sort of this turn aside all the claims? If you look up, I looked it up once. You just Google it.
I'll answer your question.
You're aware of all these things. Would you set these all aside?
I'll answer your question. So, CSIRO, which is the Australian Research Institute, did some of this research. Some of it's funded by the meat industry in Australia. The research is good research. The numbers mostly are convincing. You've got to remember, 94L is what I describe as a partial, and it's probably one of the least compromised of the partials. So it's quite close to wild type. Single copy, you'll get some of the musculature benefits, double copy you'll get more, but also the research around whether or not you get all the calving difficulties, milk difficulties, problems with the mitochondria and so on, most of those are not as perceptible in the cattle that you get. Okay, that's in limitants. Okay, I don't know what it would be like in another breed. I know what it's. We've got one. I think we've got a few versions, very few copies, less than 10 in the entire herd book for shorthorns. And I suspect somewhere back that was introduced by a bit of upgrading, crossbreeding that wasn't recorded with limitants, to be honest. So it's very rare. So we can't really make a judgment on that. At the end of the day, you have to make a decision. All I can tell you is that that's probably the least pronounced of the myostatin impacts if you use F94L. I will give an opinion. However reputable the Limitants Society is, they, just like the Shorthorn Society or any society concerned with trying to get more cattle registered, we want to tell you the best. We want to tell you the best, we want to tell you the virtues of the breed. And well, that was a wonderful bit of marketing calling it the profit gene. And you're right about the meat. Different markets want different meat. But I will share this with you, that we've got a meat cutting facility near us called Swaledale Foods. I don't know if you've heard of it. And they will only cut animals like you describe. So they're all Galloways. I mean, if you actually see the third rib cut through, I think it's full of fat. I don't think I particularly want to buy it, but they just can't produce enough of them. Whether that's to the restaurant trade and catering and so on and so forth. So there is a market. Is finding the market. But if you want to produce beef that your local butcher is happy having on the slab, so that people come in and they go say, well, that's a fatty old piece of meat, I don't want that, but I'd rather have that which is off the venison, then, go down that route.
Sorry, I don't think with Moilie's you'd go down, like, you wouldn't have a carcass like the limousine because the Moilie has a lot of fat.
Yeah.
You may cut it down by, it says 10, I can't recall the figure, 10, 15%,
Yeah.
which would actually, for most butchers, would make it presentable, would make it better, not like the butcher I had who wanted to throw all these buckets of fat out. So I don't think you would lose all of your fat, you wouldn't have a limousine type carcass, but you'd also have more tender meat. A lot of people like the flavour. You wouldn't lose the flavour of the Moilie meat. It's the flavour plus the tenderness, and you wouldn't lose that.
You'll only know by trying it.
Yeah, but from my experience now, I happen to, without knowing, I happen to have a book who was F94L. Now, I used them and I produced, kept 7 heifers, out of them, 7 heifers. I passed them on to another breeder. I didn't know he was carrying this thing, and I found out later, of those 7 heifers, 4, I think it's 4, have the F94L.
Yeah.
And the classifier was round. There's a person from the society, he was well up in the society, he was round also looking at the cattle. I pointed one out. I said, do you think that animal has F94L? He said, no, she doesn't. But she does. But you wouldn't know to look at her, you know. But the other point was, the classifier was there yesterday, when there's gone out, one heifer's gone out, and I just made the comment, that's my favourite heifer in the group. And he looked at her and he said, I can see why. And he made her EX92, third camper. And she does carry the F94L. She's not extreme in any way. She's just a square animal. The type of animal I would like to breed, that I want to breed. And you know, she does carry a single copy of the gene, and that is what the society, in one sense, we're classifying and we're trying to produce an animal like that, because the classifier is very happy. She fits the characteristics that the society's laid out.
Yeah.
You know, so that's why I would like clarification of these other claims that can 94L be looked on differently from the others, because I know all these. I don't want to run into problems with calving problems and all the rest of it. And that would be my fear, you know. Can you believe? Now, the limousine girl, sorry, one limousine girl, the secretary, she told me that now 95% of all limousines worldwide carry F94L. It's spread through the breed, and they're a successful breed. AI services sell more limo straws near than anything for ease of calving, and yet those bulls must, if she's correct, 95% of them carry F94L. So that particular gene, that particular myostatin, I'm not talking for the other 8, must not, in my view, if they're correct. And I'd like to know, how can you find out if these people are correct or not?
Well, you need to go back to the original research and go through the papers and look at the numbers to see whether statistics supports the conclusion at the end of the paper. And that's the only way you can do it. But you'll only learn for that group of cattle. You might want to think, well, I'll give it a go with your own herd. Keep the data as you go. Be honest about your calving record. Be honest about the milk. And maybe it'll be as you hopefully describe it. But I can't look at a crystal ball and tell you that. All I can tell you is what is known. And a lot of this data is on other breeds for obvious reasons. So you're probably not, the answer to your question is you're probably not at high risk doing it. And you may well get the sort of cow that you're looking for. But, you know, I might meet you at a year's time and you go, well, you said it was at low risk. Well, I've just had 2 cow deaths, or So, you know, we all are playing the 9-tile, you know, those 9-tile square games. We're always trying to move them on the right bit, and the last tile never quite goes where you want. That's what we're all trying to do the whole time. So I don't know is the answer, but I can tell you that what I have described is what we do now.
Yeah, sure, but I'm trying to get a distinction between F94L.
I know you are, but I'm not going to give you one. and I have this the whole time with people, you know, because we all try and create a story that works for us. I've one of my short haul breeders who is also from the province.
But you think there's no, sorry to interrupt there, you think there's no scientific justification for that view?
I don't know, and I don't think the research is that compelling. I know that there's a lot of what we call observational information based on Limousin herds, mostly in Australia, that looks very promising. And I know a lot of that information is being transposed on behalf of the British Limousin Society, because actually it's a great marketing point. And actually, it seems to work for Limousin's, but I have no idea how it would work because the Moilies, however crossbred they are with other things, are a very distinctive breed. The core of the genetics is quite resilient, notwithstanding how many few animals it got down to. I mean, I wasn't going to talk about Moilies, but I'll just sort of go on and need to get them to come into the conversation. But I will say one thing. So, growing up in the 60s in Ulster, and I, with my friends, we'd cycle around the farms, we'd go and visit friends at farms, and a lot of farms, certainly on East and Fermanagh, Tyrone, Northern Monaghan, some in Southern Armagh, they would have what we'd probably call Moilies. They would only probably have 2 or 3. They would be house cows. They'd be mostly used for milk. They'd probably cull them after about God knows how many years, and then they'd use their own meat. And that was the model. In fact, in some farms down in the Republic, you might see something similar still. And I saw things that people say, they didn't call them Moilies, they just called them Moiled cattle. And some had black specks in them, and I never saw any horns, but all I'm making the point is they were functional cattle first, and I think as we all want to develop breeds and all the rest of it, I think they've become something that people wanted to standardise for obvious reasons. How you use them, and it's up to the breeder at the end of the day. But I can't use that Australian research to support or deny what you want to do. You've got to check it out yourself and then tell the rest of the society whether it works. Anyway, so I'll not do it.
I think Sam's actually asked you've answered the question. The question was going to be, is there any evidence there's significant differences between the different genotype mutations? And I think you said no, there isn't.
Well, it's not persuasive. I mean, it's a bit like you take. So imagine it's a dose. You're giving a dose of this protein. So a full dose will stop the musculature, anything in between, right down to the full blown. And it's certainly true for these partials that they do give a dose in between. What we're not clear about is how that impacts on all those other different genes that obviously go towards all the things that have just been discussed. Because it isn't just one gene, one impact. It's one gene, and then it's shooting around like a pinball machine, firing off other things happening. And it may well be that firing off the other things happening in Moilies is different from it is in Limousin's. Because the benefit of the Limousin's is there are so many of them, and there's been so much standardisation around the breeding that it's probably a more consistent genotype collectively than you probably have with Moilies at the moment. That's probably the best answer I can give.
Just, Ron, you made a point there about residual benefits. If it didn't have the gene, it would still have some sort of, like the boys are a small population, there's about 1,600 registered. We have probably, I think it's 12 bulls, there's somewhere around 12 bulls showing gene.
Go for 14.
And there's a possibility from that 14 bulls and that smaller population that a lot of that residual benefits could be put through the breed without encouraging it further. Would that be right?
No, I think it's a good working hypothesis. I'm just going on what I've observed with our herd, and also some of the anecdotes from other breeders. So I don't know if you've ever heard of the Chappleton herd, a big shorthorn herd up in Scotland. It's quite famous for Angus and Shorn. So they're big herds, so they can make some interesting judgments. After Foot and Mouth in 2001, they lost, I think they basically decimated the shorthorn herd, apart from semen they got stored. And they basically rebooted by getting embryos in and myostatin. And then it's funny, I was talking to Donald Bigger was the breeder, sadly he died a couple of years ago now, but I was talking to his son only 2 weeks ago, and I said, because theirs was the bull at the Scotland event. I said, I was interested that you produced such a cracking bull and it's myostatin. Oh yeah, we're going to use that before, he said. I said, I said, well, I remember talking to your dad, and he was, very keen. Oh yeah, well, we've been through that stage, he said. And then he said, and we got the cattle to where we wanted, but now we think the myostatin has done its work. Now that, implied to me that, rather like what I'd observed, there was some residual benefit. Maybe it's a bit like snakes and ladders. This is the one that took the short ladder quicker to get to where I wanted to go. But going back to an unmyostatin situation, maybe I was better off. Just tweak the dial enough. So a lot of this is supposition. There isn't any science supporting it. I think it might be worth a go. It depends what you want to do with the cattle. I think it is a dilemma, what was described, that you do want a saleable product as well as enjoying the cattle. You don't want to be embarrassed about the carcasses you're selling. So maybe this is a way to go. I don't know.
The big thing about what we're trying to do with the beef is going down basically the route that you've gone down.
Yeah.
We're looking for the specialised market, and we have worked hard over the last few years trying to corner that. We have, well, my own opinion would be that the Moiles are so far down in stature that even a productive myostatin wouldn't get them to commercial benefit.
Yeah.
So like from that point of view, I look at it, we have what we have. We have a very good product to sell, and if we lost that product, we're left with nothing to sell.
And however much you like how an animal looks, and you're seduced by the history of it, when you are from this part of the world, as Indian I am, then it's all part of your heritage, and you want to make a success of it. So I get all that. It's just how much you turn the dial and how you do it, I think. Because in a sense, Moilies were not the most impressive cows to look at, but they served a purpose originally, and they're nice to look at, and they were great as a manageable cow. That was the other thing. Because remember, I think the way the commercial market is definitely pushing back down on smaller animals now. The smaller cuts of beef. So obviously, if you can find ways of improving basically the meat offer, that's great. But the amount of Dexter, Galloway, and now we've got the low-lying cattle that have become very popular. The market is pushing towards smaller cattle. For shorthorns, we've got some breeding cows that are up near a ton in some herds. We try and aim for about 680 to 720 for a mature cow. But for some, even now, that's quite a reasonable sized beast. So that might be one of your unique selling points is the size.
Well, if we're looking at grass-fed, trying to grass-fed, trying to outwinter, like those are two big characteristics for the Moiles. Do you see the myostatin being detrimental to both those?
And you'll get, so I think that is a huge benefit. And remember, your cost base is going to be a lot lower. Because that's the other one thing, and I say this as a father who's done all the stuff and go, oh, we sold this for that, we sold that for this. And the reality is, you might be the person selling all your animals at market for 1,800, $2,000 for a 18-month animal. But if you're spending £800 or £1,000 to get it to that point, it ain't that impressive. If you're hardly spending anything on your Moilies, and let's say you're only getting 700 which is better,
Well, I always remark on the orange shorthorns, I don't know if you're aware of them.
Yeah, I know about that.
They're quite and the guy who runs that operation said to me, he said they were in the Belgian blues, etc., and his terminology was that they were vanity farm prior to his going into the shorthorns. He says it was all about getting a big price. People didn't realise the destruction to get them there. And that was what they said.
Doing the easy exam questions always best. And then stay consistent high averages are better than the occasional P of the Farmer's Guardian published figure, isn't it?
Yeah, I just wanted to ask a question about, I suppose, I find it slightly surprising, shall we say, that if the myostatin gene came in the 1980s with upgrading, how come we only have a small number of single copy animals? Surely in all those years, when all of those animals that probably had myostatin are involved in nearly every moilie that's living. Or is there something else? I just find moilies, I mean, the pole thing in moilies also, we ought to have lots of horned moilies, because Sam just told you we used Shorthorn and Ayrshire, Jersey. Those, nearly every moilie traces back to some of those. So there ought to have been lots of, but they're not. We do know that the Celtic pole gene or pole test is not accurate for moilies.
Interesting,
So can we be confident that the myostatin one is totally accurate? Or is there something else? You know, there must be another gene affecting the pole thing, other than the ones we're used to.
I think it's a really good question. So I think the answer, if we got back that picture on there that showed, you know, sort of the cascading effect, lots of different things going on. So what I think about it is interesting in what you describe is, the short answer is there probably is another POLD or another gene that's implicated in POLD. I mean, the Moilie has a very distinctive head shape. And what we know, and again I'll use the Shorthorn reference point, is that the head shape between a horned animal and a polled animal is different throughout the skull, even to the width of the muzzle, and you know how concave its nose is and all the rest of it. You know, we used to see that with certainly some of the Canadian polled animals, the heads were hugely long and thin. So there's whole range of different things going in, and it may be for moilies they've got a very distinctive skull shape. It may be there's something else playing out, just as you suggest. The only way to find that out is probably to invest in doing some, you know, basically sequencing the whole genome, and then getting someone to have a look at it. Now that, you know, you need to cost that up, and maybe there's some grant money to do that actually. That'd be worth looking at. But that would be the way to do it. And that may answer your question around the myostatin, because it'd just be interesting to see, there's something I didn't talk about, because I didn't want to go into loads of kind of science nonsense, but you just imagine that all these genes are on segments of DNA, hugely long, and when basically the sperm or the egg is produced, to make sure there's diversity in the next generation, there's something called meiosis, which you may or may not have heard about. Basically, there's a reshuffling of the genes. And the ones that are close together are more likely, because they're close together, to be carried forward into the next generation. Ones that are further apart are more likely to be split apart. So maybe there's a couple of genes associated with either both the pollen and also the growth factor stuff around myostatin, which are close together. And that's what characterises why moilies are different. But you'd need to do the genomics on it. It'd be a great piece to do. And if you'd had the genomics, you'd probably be one of the few, I think you'd be one of the few breeds to, because your numbers, you could probably do it. If you genomically, got the genomic sequence for all your 14 bulls, you'd be probably the only breed that could characterise all the successive generations, which would be fantastic. Now, I said I wasn't going to get into Moilie politics, but it is fascinating.
Just want to touch a bit more on the residual effect. It's something that I've really, learned here tonight. I suppose I have to explain the question I'm asking in a different way. So if a cow, say a cow is a single carrier for Myostatin, say if it's F94L, I assumed before tonight that it was like a switch. So see, she had a son, right? I assumed that switch, if her son was negative for Myostatin, I assumed all the benefits were gone. Now the visual benefits, the phenotypic benefits, okay. So what about the detrimental effects? So for somebody, I know you've deliberately, I've been listening very attentively and you haven't mentioned it, but what I'm thinking is someone with a myostatin free herd, if he was wanting to buy a bull and keep his herd myostatin free, if he bought a bull out of a cow that was a carrier but the bull was free, what
Would that pass on?
would he bring side effects with him, the detrimental effects, or would it be a benefit to that person?
Okay, so I'm going to give you a scientific view to explain what I mean. So you know when I explained that for each egg and each sperm there's a reshuffling of the genes?
Yeah.
What I think is happening is I think because there are very similar genes to myostatin on the DNA, it is highly probable that they are on very close segments of the DNA, because that's the way the biology works. You produce multiple copies, they slightly change, they do slightly different functions. And what I suspect is happening, that in the reshuffling from the myostatin generation to the non-myostatin generation, is you're getting some of the genes that work well with myostatin come through, but you're losing the myostatin deletion, if that makes sense.
Yeah, I'm sorry, I understand that. Yeah.
Now, how they would operate minus myostatin, I just don't know. But what I do know is that it seems, from what I've described, and also from the Chapelton herd and a few other sort of anecdotes, is that you do see some conservational benefit that stays behind. Now, I have no idea whether you get, the milk changes, all the rest of it. I haven't observed that to be the case. So I was talking earlier that, one of our shorthorns that would fall into that category, a cow, it's actually a first generation out of a myostatin positive animal. She produces a huge amount, sort of nearly 30 litres a day milk. Lovely, beautiful, tight udder. She's got one teeth that's slightly too big, but and perfect. So clearly her milk's not down. That cow, and I can't explain this, but that cow in 6 calvings has only produced heifers. And she's one of our best cows. Now, was that because she's out of myostatin? Don't know. I know she's a good cow, and she's certainly better than the maternal line was previous to her as a result of the cross. I'd like to think it's how I described it, but I've nothing to support that. It's just stop the nice stuff.
Can I? So this is more an observation than a question.
Yeah.
Obviously, we thank you for outlining the sort of the science behind the myostatin variants, and it sounds like, and you can correct me, that the Shorthorn Society doesn't restrict the myostatin variants, as in it doesn't put animals with particular variations into a different class in the herd book.
No.
No.
It's only double copied bulls that we don't register.
Oh, so you do. And as you said, everybody has to make their own breeding decisions. But I think we have to be careful. We've got no one here. And Brian talked about breeding confirmation. You talked about breeding for confirmation without myostatin, which is an unknown known, or a known unknown. We're breeding for a trait, we just don't know what the gene is. And I think we have to be careful to realise that we should be cautious of discriminating against a known variation just because we know it's a variation, if that makes sense. So we know what's causing this, but there's lots of other things we just don't know. We don't know what improves, and yet we don't discriminate against those.
What you're saying is absolutely right. So just because we know it and see it and it's characterised, then we could do something about it, positive or negative. But as you say, there's a load of other stuff going on that we don't know. Now, but actually, you can take lots of different views on this. The stuff we don't know going on is actually what breeders have been doing anyway, completely blind. But that's why I said about doing the full sequence on the 14 bulls, because you may not be able to find out immediately, but that will always be there. The trouble with SNPs is, SNPs are just little samplings, and you might say that, you know, because they're all numbered, that, you know, 10 and 12, for argument's sake, map to myostatin. They don't, but I'm going to say. Or they map to TH, or they map to this, so you can say whether or not there's TH there. And that's what's happening at the moment. But if you did the full genomic on it, even if all the science to identify the individuals might not be there now, in 5 years, you might say, that's, you know, we can tell what those balls are. And actually, because we've got 5 years of reading after it, we can now tell exactly what the consequence of. It would put Moilie's streets ahead of everybody else, because those unknown unknowns, without getting too Donald Rumsfeld about it, you will be able to characterise them. And that would be great value probably for other breeds as well, because, you know, once you've identified it, you know, you might have a situation like with the Celtic and Frisian pole genes, that yours is completely different and it doesn't apply. But there's a strong probability it will, because most of the cattle genomes are going to be shared. So, yeah. I mean, the thing is, I mean, it's quite fun to try and understand how this works, because we don't know. But, you know, as I say, my job tonight, I think, is just to try and give you as much information as is known without putting too much subjective opinion on it, really.
Tim, I think we have a couple of questions here.
Oh, right, okay.
So I'll just to sort of summarise it here. Have you seen any differences in the show ring with myostatin carriers and non-carriers?
Did somebody? Dan didn't ask that. I think the same principle applies. You know, if you had pronounced phenotype with a myostatin, I think certainly there was a period, certainly shorthorns, where it was a faster track to show success. And also because the animals probably did better on inside cereal-based feeding, maybe, who knows. But I think it's a difficult question, because, you know, we all have cattle for different reasons. You know, some people do like to show, some people like to show as well as commercial, some people just like doing commercial, there's everything. I personally are less persuaded by the show ring, because I think we're selecting for different traits than the conversation, for example, we just had around what will work on the butcher's tray. But, you know, that's not to deny anybody the opportunity. And again, I think the same principles apply. If you think that you are going to do better in the show ring because you could change the conformation using myostatin, yeah, there's a historical precedent, because it's happened in shorthorns, it's happened in other breeds, and that's what they've done. South Devon's a classic example. But you know, when I listen to judges now, I think, and also if we look at sterling sales, which is probably a better answer to this question, if we look at sterling sales, there was a period where myostatin balls flew off the shelves. Is that still true? Not so much. Now, why isn't it true? Well, I think there are two things. One is because there's a trend not to have myostatin. Alongside that trend, whether it's residual or not, there are much better conformation cattle, and so they don't need the myostatin anymore. And also there's a trend, I think, that people want cattle that are going to do well extensively. So not a straight answer, deliberately.
It's absolutely fine, thank you.
So is everybody happy enough? Tim, I'm sure you're exhausted, ready for a cup of tea.
Oh, I'd love a cup of
Tim, thank you so much indeed. That's just a really
Oh, that's unnecessary, but
yeah, thank you.
Thank you, that's really
If you
kind.
give Tim